So my name is Niharika. I am working as a developer relations engineer at Google from past 1 year, and mostly I have worked on improvising the performance of low and mid-end devices, working with tools, resources, and working with the partners, which we have worked on Jank and ANRs, and then I started working on Android Go edition. Uh, Optimizing the apps, how you can build better apps for Android Go edition. Uh, I'll talk about what and why, like why Google's thought of having Android Go. What is Android Go? Why developers should think of building application and consider optimizations when they are building for Android Go, optimizing the app memory, startup and app size, the recommendations, best practices, and what all tools you could use, because these are the recommendations which we have got from our top Google apps, Gboard and Camera from Google team. So they have already built the applications which are the optimized versions, and these can run smoothly, mostly smoothly, yeah, because it happens. You can't really compete with every device, but ideally these work with most of the devices out there, and then yeah, many more things. Before that, I would really love to know, let's have a kind of two-way conversation because we are already in a virtual environment. I would love to know from you, how many of you know about Android Go edition devices? Because I have seen a lot of myth around it. People might compare it with, oh, it might be an Android Wear or Android Auto. So how many of you know about Android Go? You can just answer in the chat itself. Okay. You have heard about it for the first time. Okay. Okay. A few people know about that. Uh, okay, cool. So if I ask, how many of you have heard about Geo or Samsung, or at home, you might be, if I just talk about your parents, uh, because we are the smartphone users mostly. We do things on that, and we just buy something which has high RAM in it. But if we just consider our parents or someone who doesn't really need a lot of features, a lot of, and matlab, it can be a lot of things which are not really needed, but we developers are like, we need high RAM devices. How many of you have those low end devices at home? Or maybe you have seen the Uber drivers or the Ola drivers, or the delivery guys having the low end devices. You might have seen that, right? Android Go is nothing. It's just an operating system. It's a part of the main Android only. It is a kind of which the Android main Android which you already have. It's just a fork from that, and everything which you already have in Android. Just a few features are disabled so that the low end devices can perform really well on these low end devices. So anything which is like the lesser RAM, we started with Android 8.1, which was like 512 MB RAMs. And with Android 13, we have just launched Android 13, and we do have 2 GB RAM devices. So anything which is like the 1 GB or 2 GB RAM devices you see, these are falling under these Android Go devices. Mostly, and it's not like, if I just talk about like why, if we have the low end devices, we can just build the light apps, or we can just disable a few features. But why Google thought of building this for the first time, when in back in 2017, we had like, if I we just talk where our parents don't really need complex features. Someone has just written that their grandparents use the old phones, or there are people who can't really afford high end devices, or these are not maybe cheap for them, or they don't really need those features, or those animations which they see, or those new things in the phone. They don't really need that. A driver just need the driving app for them, and they just their work is done. A delivery boy just need their map application, and the driver app needs to be run fine there, and their work is done, right? Just need their work needs to be done. They just need a few features. That means the application will be light. uh, we are providing each and everything which is needed for them. Let's say we have contacts, we have camera, everything is there, which is like the necessity things are there. But maybe you don't really need a lot of animations in your phone, or maybe you don't how many of you have heard about the picture in picture mode? You might have seen that, right? In most of the applications, Netflix, Hotstar, you use the video applications. That is disabled in Android Go devices, because it's like you can work without that. The necessary thing is the video. If you are using, there will be a video player in which your video can be played. So the necessity features are there. So this was a thought behind Android Go, to build something which is affordable for everyone. Because in rural areas, right, even till now, we don't really have people who can afford all these devices. So this is the idea behind Android Go. Now this is why Google built it. uh, and other reasons are why developers should think of is, we don't really know the numbers, but like when people just talk about it. But this is something which is from the IDC mobile tracker. They have given us this number that more than 250 million people are using, and this is the worldwide number. This is not the this is not the India ones. So 250 million people are actively using Android Go devices. OEMs, big OEMs, we have Jio, Samsung, Oppo. These are building Go devices, because again, you might have seen the Jio phone next. If you haven't seen, you can just go and Google it. They are building these affordable devices just to make everyone. They have the motto for building for billions, and this is how they are. They want everyone to use the smartphones, or to use the technology around them. And if again, as if you see the numbers, there are already so many devices out there, and if the developer is not considering a smooth, optimal, performant user experience, it is impacting your business directly. uh, you might have seen, or you might be playing with some applications. If those are not working fine on your device, what you do is you just find an alternative, or just remove those applications, or put some reviews, ratings for that, right? So this is how everyone sees that. It's you are a user, you are also a developer, so you have to see your application should also be working fine. You might have built a Facebook, you might have built a WhatsApp application, but if those kind of applications which are like not running even with the necessity features, or you might have this Zomato or Swiggy, right? If these applications are not having the orders screen, or the cart, or the critical user screens are not working smoothly, you might not feel the same user experience. Or if you are finding, again, if Zomato is working fine, why would you go for Swiggy? Or if Swiggy is working fine, why would you go for Zomato, right? You will see Twitter Lite is there, you will see WhatsApp Lite is there, you will see Instagram Lite is there. These applications are built with those minimal features, so that they can run the necessary things, and other things can be disabled. So yeah, Shashank, I told the same thing. Yes, light apps are built for these Android Go devices, but people don't really know Android Go. So these are just, again, the lesser RAM devices. Lesser RAM is, as I mentioned, with 2 GB RAM. Uh, we are talking about why developers should build for Android Go. So if developers need to build for Android Go, they do need the techniques. They do need to finalize and come to an approach how they should start thinking of an optimization. You can't really go and just think about, okay, I'll just optimize my app memory, or I'll just optimize my app startup, or I'll just optimize my app size. You can't really do that, because if an application is a large application, you will always be you have to have some target for that. Otherwise, every time there will be some complex features coming in. It's never like an application is a stationary, or you have just built all the features and you won't be having adding. Things will be complex, things will you will implement more features on one screen also. So there will always be chances that complexity is always increasing, and your screen might not behave smoothly if you are just adding and not considering optimization out there. As we just mentioned, the ratings and reviews, the business impact, everything is related to this. And you yourself is not using any application which is not working fine, right? So why would you build something which is not, which will give your users, which will won't be giving your users best experience out there? Before that, you should be always having some approach how one should be thinking of optimizing an application. As we just mentioned, you can't just really go and think of building optimizing memory, because it there comes a lot of things out there. How many of you know about key performance indicators? Any example of key performance indicators? If you just build your application, or if you just consider implementing an application, what are the key performance indicators for your applications? Anyone? App startup time, okay, yeah. Jank. Yeah, these are okay. Now you know your application very well. You know what exactly you might have a crash rate which is like bad for your application. Other application might have app startup latency. There are few key performance indicators which are common to all the applications. And I have given one example. Let's say I'm using a camera application, and I really want the image processing to be done on time. I really want the bitmap should get processed and stored within the time, and everything should happen in like just a few seconds, right? Yeah, the clicks should respond as much like minimal time, right? So everything, these are the key performance indicators. You need to decide for your application what all are necessary for your application, prioritize them, and then pick one of them. These were the key performance indicators. After that, you need to decide on, even those key performance indicators might have many things. You can't just really go and I just say I want to fix app crash rate for my application. You have to consider, are these crashes due to some unhandled errors in your code? Are these crashes due to your any high memory usages or any ANRs or anything else? You need to categorize, and you need to find out which one is impacting your application higher. Those the highest one is maybe the unhandled errors. You need to find that, and you need to start working with that one. This is how you start breaking these metrics, app vitals, and you start thinking of one thing, and then you proceed to others, so that you will always be clear of what exactly you need to fix. Or maybe you can divide that within your team. Let's say one is fixing the crashes, one unhandled errors, one is fixing from any other crashes. So you need to decide and break down those in individual metrics. Once you have decided, you have to benchmark that. Everyone, you can't, let's say I am working on my home screen, and I just picked app startup time needs to be improved for that. How would you benchmark? Are you improving or not? You need to decide and balance, even if you are adding maybe some complex features, these were not there already. If these were not there already, you won't be able to benchmark, right? You need to decide a time in your sprint, when are you going to pick those optimizations. If that is a startup time for just home screen, or maybe card screen, order screen, these are like, I am just giving a few examples, but your application, it can be anything. If you have decided that, you should have a number in your mind that you are going to fix by this amount. These were the issues, and you should be able to compare and measure. If you're not able to compare, that means you are already doing some mistake, or you're not able to measure the impact of that screen, the vitals there, how are they performing well or not. You need to benchmark, and you need to consider those. Once you have done that, maybe I told myself I will be fixing maybe 30% of the issues, or maybe 40% of the crashes. If your target is not around that number, maybe you just fix 10%, or you thought maybe another feature comes in, and you thought you just deprioritize that task. That shouldn't be there. I know there will be features where your PM needs them to be out as soon as they can, but you need to balance in both with both the things. Till the time you're that 30% of that target is not met, what happens is you might be adding more complex features, and the optimizations which you have already done, these gets merged with the complex features what you have done, and again there's no use. You are not able to benchmark clearly. You are not able to even, how would you measure that when it goes to production? If you have already added new features, if you have just you decided a number but you are not able to meet that, how would you convince even the leadership that you were doing some optimization and these are good or not? So you need to do this process, repeat this process till the time your target is not met. This is one of the common mistake what we as a developers do, not exactly writing the test. I know these are like debatable. People are like, okay, I'll do the testing takes a lot of effort, or testing takes a lot of time, might be I just have a small feature, why would I just add test? So anything, let's say you just forgot to add something on your payment screen, and you didn't add any test, you didn't tested it, because humans are again prone to error. They might haven't just tested a few use cases, and your server broke someday and app just started crashing. Something which crashes on payment screen, that's kind of again impacting your business directly. People will be like, they, even I, if I am using some application and I just feel like something has happened on my payment screen, I just made the payment and I'm not able to see that. It is just showing me that okay, you need to do the payment. How would I react? I'll be like very furious about that, right? So but if we have asked a machine that okay, in this case this will happen, and if you haven't provided this value, you should have error case, or you should show some error dialog. Machine remembers everything how you have asked it to remember, right? Humans might do the mistakes, I know humans write those tests also but you have written that somewhere, and all those cases will always be handled and tested. So you need to decide on frequency as well when you will be doing all these regression tests, or how often the test should run. Everything should be decided. This is how you should approach any performance or any optimization thing in your application. Once you have decided that, let's come to optimizing the memory. How many of you think of memory cases when you are adding some libraries in your code, or maybe some bitmaps? How many of you consider memory also? Because I have seen a lot of hype on startup time, even the app size. Now janks are also common, but I don't see many of developers optimizing memory also. How many of you consider that? Or maybe you just add something, you just release a feature, or after that you think okay, after some time I'll just pick this feature again and do all the optimizations needed there. How many of what kind of developer are you here? The former one which do consider all the optimization, or the later one which put some time after the things are released? Which kind of developer are you? Anyone? You can answer in the chat. Okay, the later one. Okay, you okay, depends the business. Okay. Okay, cool. Uh think memory is like, so I'll just give a few pointers on how you should look at memory or anything which you are adding in your application. You might know a few of these already, but when you are building for low end devices, you really need to consider these cases, because these are again from the live applications which are already there. As I told, Gboard and camera app, they have done a lot of optimization around these, and now just one application from them can run on low, mid, and high end devices. Every device. This is like again the common one, scheduling the tasks which really require the similar resources like CPU, IO, memory. Uh, okay, what happened was, if we had a few, you might have considering like rendering a bitmap, there can be some calculations happening on maybe you have something happening. There's just one main thread, right, which is handling all the tasks. And if you aren't considering the handlers, threads, and again there are a lot of third party libraries out there also, if you aren't considering how the handling should be done, it will really hamper your task. Uh, Concurrent scheduling could lead you to multiple memory intensive operations to run in parallel, and they might lead to them for competing for resources. There can be deadlocks, or this can exceed the peak memory usage for the app. Every application is allocated some memory in your application, and there is some peak memory also there. Camera from Google team, this is one of the learning from from Google team. They found multiple problems around this, and they ensured that there should be a cap to that peak memory, how the application would be using. And then they further optimized by appropriately allocating the resources, like separating all the tasks which need CPU work, which needs the low latency. Let's say I just need a few things for my good UX. Good UX I mean here is the developer should see something, and I might be doing something in parallel, right? So they divided all these tasks based on that. Then there were IO tasks, scheduling these tasks again in right thread pools, executors. This was the main thing which they adopted. And thread pools is actually one of the major thing, the standard common thing which you, if you go with other libraries also, third party libraries, you'll see these concepts are getting used there. But you really need to learn how exactly are they working, because if you know that, you will know any kind of library which you are integrating your application, the performance impact of that application in your code. So you really need to learn the concept of multi-threading and thread pools out there. Then you have, how many of you use on-prem memory? I know most of you have heard about on-prem memory, but I'm not sure how many of you use on-prem memory in your application. Anyone here uses that? Okay, I don't see an answer there. So what happens is, in your on-prem memory, this is always proven useful if you just have to trim any unneeded memory from your app process. It provides you different app state levels. Let's say your app memory is critical. Your app memory might be having uh, like it shows you a level like low, moderate, high, the levels by which the memory is getting low. So when you are getting signals around that, what you can do is, you know your code, right? And after that, you could just remove some resources, recycle some resources, maybe release some bitmaps, or maybe you just don't need some animations, anything. What you can do after getting these signals, you know your code, right? But utilize this memory, this method out there, and this is like available from, since I guess I'm not sure right now, but I guess this is already available from your API 16, I guess. API 16, I don't think most of you are using there, but yes, on-prem memory, a developer should be utilizing that. It's not just for the low-end devices. Anything you don't really need, you can just release it in on-prem memory. Then you have memory leaks. Of course, these are the ones which you really get to know mostly. Memory leaks are like, you might be using leak canary also for that, and just get to know, okay, which objects are taking a lot, or these objects, maybe you use some global resources. These are like static or singleton, which are like global in the whole application and already out there, and you can't be really you are using it in every class, right? You just made it that static or singleton. But how many of you think that static and singleton can be harmful also? Have you ever any faced any kind of issue with making just anything static, or maybe just because there are pros of using that, but there are cons also. So anytime you are using these, please be mindful. These are just a few examples, but you might be you need to use some libraries. Or memory leaks are the ones, what happens is main thread is working, and if I am just scrolling a screen. Let's say I am scrolling, browsing some clothing application. After some time, if there are memory leaks and the resources are always allocated, what happens is your application needs a memory, right? After some time, your GC starts calling frequently, and if that is getting called frequently, uh, your main thread is not getting the appropriate time to run the task. And after some time, it will just slow the application. You will see start the application starts lagging. You will see the janks, and after sometimes you might see the application not responding because main thread had to do some task at a particular time, but it was not able to do. It was asked to do something, but it was not able to do because it was not getting the enough time to run and at the appropriate time at which it has to be run. So you need to fix, and these are the ones which you will be able to find easily. Then again, optimizing your bitmaps, that is for sure. Most of us are doing already. Large images and drawables always consume more memory. What you can do is, if you have big drawables, you can prefer the lazy or on-demand initialization in your code whenever you need that. Release the views if you don't really need that. Uh, we have some full colored bitmaps. Uh, you should, so there are full colored bitmaps. You could search about it, and if possible, please avoid, if you could just avoid using those full colored bitmaps, at least for the low end devices. uh, Glide, Gboard, our Gboard application had this with the glide typing feature. Gboard is the keyboard application. You see the Google keyboard, right? Gboard is Google keyboard here. So Google keyboard has the typing feature there, and what happens is it has an overlay of bitmaps there whenever things are getting drawn. So they did some optimization and they removed these full colored bitmaps because these were not really needed. So try to see and look at your code if there are some full colored bitmaps, and these can be avoided. uh, okay, this is kind of a trickier one, and again, it's not like everyone is using these functions, but if you are really dealing with read only and large files, try to check malloc and mmap functions. So malloc is, how many of you have heard about malloc? Mostly what happens is we get to study about this when we are in like our college days. Malloc, so malloc is the memory allocation thing. When we And mmap is basically memory map. It is basically used only when you are reading a large file into memory, and that is like the read only memory mapped file. If you have some use cases in your application where you are using reading large read only files, try to see if malloc and mmap, try to benchmark and try to compare both of these, what you should be using, and balance again along as per your memory allocations. If mmap is performing better, try to use that one. This one is again is it's not the common use case with every application, but yes, mmap is getting used by many applications out there. As I just mentioned, one is the Google app itself. They are using it whenever they are accessing the read only and the large files out there. We talked about the memory part. These are again a few recommendations which we are just talking about because I can't really cover everything at one go, but these will give you a few indications whenever you are building the app. Try to see and try to look at it as a user point of view also, and these will give you the top pointers where you could start looking at the memory part. Coming to the startup time, you must have seen a white blank screen whenever when you go for you might launch an application. uh, you have clicked an icon and it is taking some time in between while launching the application, or there are just some blank screen. No one likes that, right? You might have seen in many applications, if not yours, but many applications out there. For startup time, there are so many things which one should optimize, but let me start with the common thing. What we do is when we start implementing an application, we put every initialization in our application on create. You need to consider one thing. If you're there are so many you have the four components of your app and in Android, right? The activities, services, broadcast receivers, content providers. Broadcast receiver services, these run on the main thread, right? Anytime any broadcast is there in your application and any service needs to be run in the background, it will wake up your main thread, right? and your application on create is getting called every time. You need to consider what all applications can be put in the in the background thread, what all are really not needed. All are providing you those on-demand initializations. Every application has the content provider also. They save some shades, they save some data there. So they are providing the on-demand initializations also. You need to balance, identify which occupy the large time frames and can be optimized. Identify the operations that consume more time than expected. Then again, if there is something which your main thread is getting blocked, you need to again find those obligation those libraries and frameworks. And mostly, again, the third party initializations you need to check. What happens is, you might be putting something in the big background thread, but those third party libraries are doing something which really needs a work needs to be done synchronously in the main thread. You need to balance in out there. Check the rendering time of those whenever you are working with the third party libraries, and be cautious. People just see any library, or maybe just for a one view, custom view, they just put the whole library in their code. Just be mindful, whatever the data they are taking, whatever they are doing in the background, or whatever initialization they are doing, you need to consider everything, because application main create, this is the main reason for every, even the startup time, ANR, jank, most of the things happen if your application main on create is not working really well, or many, it is like heavily loaded, and other tasks are not getting performed on time. Again, avoiding the eager initialization. uh, there are something, the user launching your app is again the most well-known reason for a process starts, but you might have other things like the work managers, job receivers, bound services, content providers. These are starting your app process in the background. Avoid all initializing these things eagerly in your application class. Like, or you have now got the Android X initializers there, which are providing you all these on demand and lazy initializations. So if again, if they are not really needed for any possible reasons, just try to look at what all can be moved to the background or on demand initialization. How many of you have heard about strict mode? Whenever you are working or developing an application, have you ever got a chance to look at strict mode there? Anyone here? Have you heard about strict mode? Okay. So what happens is, strict mode is used in our development environment. Anytime you are working, you need to find out if there is something which, like, by mistake you have added something on the main thread, some network access, let's say, or maybe some UI operations or animations are getting take place, and something else is blocking your main thread, or these all these you can find from this tool. But be cautious, you can use this tool only in your development mode. This can't be really used in the release mode, but it actually gives you a lot of information of anything which is blocking your main thread. It You can just provide some warnings, or you, if you want to terminate your application if these kind of things happen, but everything will be there in your stack trace in the logcat, and you can just find out and read what it will give you, even the line numbers also, and the reason. Like I just mentioned, the disk read contention, that means some IO network call is happening on your main thread. You need to find out all these. There are tools available, but we need to be aware of these tools also. IPCs are the inter-process communication. Let's say I do have some image or asset loading, some third parties libs getting loading, or some, again, the heavy application on the application main thread, some heavy work is happening. Uh, Even this can be found from the strict mode. And also, uh, as one thing also I mentioned, the libraries or third party libraries you are using, you need to be very cautious about that. They might be doing something on the main thread which you are not aware of, because this has, when I was working in my previous organization, we have got some issues like that, where we were not doing something on the main thread, our application startup time was not really great, and the third party libraries which we have integrated and initialized in our main thread, these was causing the issue, because everything from there were few libraries, I don't really want to name them right now. There were few libraries which were doing something on the main thread itself, but others were advanced and they have moved everything to the background then. So that really caused some issues to us, but we were connected directly with those teams, so we had to ask them to move and provide us an updated version there. uh, we have this XML and JSON parsing. So what happens is, again, even this is not a use case where everyone work on the JSON. Mostly you might be working on the JSON parsing itself, or you might be working on the XML parsing. Uh, a Gword application find out that they were parsing a file list there, and they optimized that by using a Java code instead of the XML parsing there, as they were parsing them out into the memory and as Java objects at runtime. So this was taking a lot of memory for them. What they did was they did a work to convert all the XMLs into Java code at compile time. And now the things were getting done at the compile time. The latency of whenever they were loading the time of the class loading, that became like much more faster, and that was like the almost one fifth of the previous time which they were taking. So again, this was one of the use case where they had to do the file list parsing. They benchmarked that one fifth of the time is like a lot, right? One fifth they time by just converting the things and doing the loading at compile time, converting all these to XMLs, from XMLs to Java code. They they had to benchmark this. You will find more use cases when you work with your application, that okay, I am working, and if I have a use case where the parsing can be easy with XML or the parsing can be easy with Java, you need to decide for your application also. This is, again, I'm just giving a pointer. You need to decide for your application if that works really well for you or not. Then we have talked about the memory, we have talked about the startup time. When it comes to low end devices, you need to be cautious also, because uh, as less as the app size is, it will take again lesser memory there, and you can have more space for other applications also. So you need to consider that too. uh, you need to just check anything which can be like, there are some layouts. If I just talk about, let's say there are two screens where you might have added a few text views, or you might have added a progress bar there, but they look alike. If you are considering the low end devices, try to check if you could reduce those layouts and can convert to just one layout. And at least for the low end devices, you need to consider those cases where you could just have one standard screen which can work for most of the cases if they have something, most of the things in common. uh, have you heard about view stub or merge tags? Anyone here have you heard about view stubs or merge tags? Okay. View stubs are like, if you really find out that the layouts which can be dynamically rendered, uh, anytime you are rendering something, right, that will take time, and that will again take the size also. If you really don't, maybe there is a use case where you don't really need a discount field, where you don't really need an error dialog. Why would you need to render that, right? So what you need to, there are a few tags, or there are something available already there, as I just talked about. Yeah, the invisible views, where you invisible are like they get rendered only when again you have provided them as a view stub. They will only get rendered if they are needed. Maybe you have provided some logics there, right? So you need to again check these are already available, but you might not be utilizing them in a correct way. Now, as I'm considering the low end devices, right, there might be some screens which are having a lot of animations, large GIFs are also there. These might work well with your high end devices, right? But again, these are taking a lot of parts of your applications. If you just, there is a setting screen, or there is an about screen, which are not really needed, but you have put something in your about screen where you are showing an animation for your application, or your app icon is like that. You need to consider if these DAU is like the daily active users. You need to consider and evaluate your features, if these features can be just removed or disabled on just considering the memory for any device out there. If you know, like let's say the device has lesser memory, you could just disable those features out there. Try to again reducing the dalvik code size. ProGuard, any, I think most of you are aware of that. ProGuard, just utilize again. Even with ProGuard, I have seen people just write the standard rules out there. You need to again check the libraries also. You need to check what can be shrinked and optimized, uh, and be cautious. They can't deal with the codes guarded by any runtime constraints. If you have just some runtime constraints, the ProGuard doesn't really deal with that. Replace those check with the compile time constants to make the usage of the optimization tools. You need to find out the libraries. If they are something which is having the runtime constants, ProGuard will not be able to optimize that. You have to replace all these flags or checks with the compile time things. Otherwise there will be no optimizations. You might consider that, okay, I have added the ProGuard, it is enabled, but it is of no use till the time you haven't seen and validated that is it having the runtime constants or the compile time constants. Then you might have now, when you upload your application, you might have seen the Android app bundles. How many of you know about Android app bundles and dynamic delivery features there? You should have seen the .aab files. These are the Android app bundles. So now Google Play uses the your apps bundle to generate, and this will serve the optimized application according to the device configuration. So only the code and the resources which are like needed for that particular device. Let's say I do have Samsung device with 2 GB RAM, or maybe someone else has an Oppo device with 4 GB RAM, a different processor out there. Every anything, we both will have different assets and resources in our devices based on the device configuration. I might receive some other assets, or maybe my application is optimized more because I do have a low end processor or lesser RAM there. So Google app bundles is like very doing this work really well. You just need to again implement this and upload the applications with app bundles only. Dynamic delivery feature is like, let's say I have a video SDK integrated in my code. I'll give you one example of my previous application. We had the 1mg application had doctor consultation out there. Till the time someone is not buying the premium pack there, they won't be get able to talk to doctor, right? And they don't really need that video SDK to be there. But that video SDK was taking 30 MBs, and this was increasing a lot for our application size, right? What you can do is these kind of features where you feel that the dynamic, you can just dynamically download these features whenever they are needed. Try to check and try to use this dynamic delivery feature there. App bundle delivery features both are a good combination. Try to check and evaluate your features accordingly. We do have many kind of strings getting used in our code. What happens is whenever you are you might are just doing translations where you don't really need the translation. Let's say if a string is there which you don't really see on your UI, why do you need to translate that? Something maybe you are just using for debugging or exception messages, you don't really need to translate that. Some URLs are there, so you need to be cautious about what you are adding in your string.xmls. Any unused alternative resources which is there in your application. Maybe you are just using some languages for your application, English or French, but other languages are not getting used. So you need to find out and remove the unused resources for your application. Anything which is like internal only, What you can do is, there is a flag that is translatable is equal to false, because all these things take time and all these things take resources in your device also. You need to be cautious of anything you are translating. Is that, or is that actually needed or not? You need to decide for your application. You don't really need to translate urls, right? You don't really need maybe some mostly what we do is, a developer comes, another developer has just added something, and they just duplicate the strings. You need to find out those duplicate strings also. There should be common standard way in within a team, that everyone should be working with the standard format, and they would be able to recognize, okay, this is the string already available there. You don't really need to create any separate strings for all the caps or title cases. There are methods available, right? So we just do a few mistakes there, and we don't really know, the impact might be little, but add all these littles, right? After some time you will get something which is like taking a longer or larger app size, right? So you need to consider all these cases. So this is how we just talked about all these. There are some tools available for memory. You might have heard about Perfetto. If not, Perfetto will give you the real time information about the CPU usage, memory, even the startup after an Android version. This will tell you any method, the timestamp, how much time any function is taking, and which phase. A view has different phases. It takes, there are we do have layout phase, measure phase, draw phase, rendering phase, right? Everything you will get to know which phase is taking longer. Do you need to optimize the complex views? Do you really need to optimize some animations? Do you really need to optimize some rendering? You will get to know everything around there through this Perfecto tool. It gives you a lot of information, not just the CPU usage only. There are some command lines, the mem info, then the show map. Now what happens is, how many of you have heard about these? Because mem info and these are like, it gives you the real information about how the app memory is divided. Your app might have some Java code, your app might have some native code, your app might have some code where something is taking from the shared libraries are taking some memory, or again, the Java and native stacks. Every information, if you really need to deep dive and you really need to fix the memory issues, you should be knowing which part of your code is taking and how much is it taking, right? This mem info command line tool will give you all this information. Check and utilize. Again, you will find all the documentation out there also. Okay, then we have this show map. Show map is also like mem info. You'll find show map. This provides more detailed breakdown of memory. You will get to know again the names and size of all the memories used by your process. Try to check that also. Then we have, if you are native code mostly, and you need to detect any memory errors, most of us don't really know about. There is an address sanitizer which you could use, and this will give you all these memory errors. There could be some codes also where you could find out the native errors, like in C or C++. You will find out all these errors through this address sanitizer tool. And then again, as like Perfetto, we have the Android Studio profiler. Memory profilers will give you, if you really want to have the real information when your application is running, just attach your device and have the see everything through the memory profiler. And if you want to run something in real time and also want the release applications, check, there is a flag which is profilable flag. You can add and you can run the application the way it is running in production. So you could also do, like, for both debug and production modes, you could also analyze both of these applications through memory profilers also. Then for startup, again, we have, as Perfetto will give you all the information, there is an app startup library. You don't really need to do anything. If you just add this library, what you can do is, you could have, uh, this startup library will be responsible for handling all these background cases, or how to actually initialize any library. Check this. If you are having a lot of libraries and you are really confused how to exactly initialize that, try to utilize app startup library. Through baseline profiles, our Google Map application, which is like getting used with many of the user base, like everyone is using Google Maps, right? Through baseline profiles, we have got like 30% of improvements in our Google Maps application. What way baseline profiles does is it will compile a few resources on compile time only, and your startup time will be again improve with that. You will get more detailed explanation when you just go through the documentation and working on improving your app startup time and the jank. Then I talked about CPU profiler. If you really want to trace just method, try to check the debug API. Combine the debug API and CPU profiler. You might know a few places where it could be like this is taking longer. You can use the debug profiler, debug API. Just add some trace points only for that method, and then you can analyze these in the CPU profilers there. Tests are available from Android 10 or above. Macro benchmark is the library which you could use and write and measure your scrolling and animation rendering time for any method you have. This will provide you an output in form of trace which you could run in Perfetto. So these are like, if you really know how to look at a trace through Perfetto, then you will be able to easily write the test and analyze the output for macro benchmark, because it also provides you the trace which can be run in Perfetto only. Then for app size, mostly you have heard about Lint, Android Studio Analyzer, which provide you information about anything which might be unused, where you could optimize the bitmaps. Or Lint also provides you the unused resources information. Maybe you also get, not just for app size, Lint provides you many more things, just giving you that yellow sign errors in your code and just asking you, okay, you might have some deprecated thing or anything might have come which is optimized also, right? Try to utilize these tools for memory, startup, and app size. There are a few resources available. I'll share the link for the slides also, and you could go through all these links. We have the Android Go. Anything again, what I say is Android Go is not just India specific. If I just tell you right now, US is the second most user based country for Android Go devices. So now you can just compare, right? Not just India, we do have low end devices in other regions also. And anything you are fixing for low end devices will really improve all the things. It's again directly proportionate, right? You could improving something for low end devices will eventually improve anything for mid and high end devices also. And as a developer, you are also a user, and if you are not liking some app and you just uninstall it, you need to consider that use case for your application also, that application, your application should be running smooth and fine. Keeping your users happy should be your first priority, because one thing is always, an app is always easy. A student can also be building that, but the experience comes in when you have to build an efficient application which will run at least like most of the devices you could run for everyone. So this is what we really require. So I'll end my talk with that. Thank you for listening. It was like a long talk. So yeah, I'll be happy to have the questions. Okay, so we do have the Q&A section. Roshan, should I take that, or will you be? Yeah.
Sure. So, first of all, thanks a lot for the amazing talk. It had so many points to cover and a lot of things. Some people knew, some people didn't. I personally learned a lot of pointers and things that I have to go and check out. Thanks for that. Yes, regarding the Q&A, you can take that up. I'll keep resolving as you go ahead and answer them.
Okay. The name suggests it's a technology that can be built Android apps with only Go language. Oh no, there's no Go language. It's a part of Android only. The source code, I know the source codes are not open, but there's same source code. Only a few features are disabled based on if they are low RAM devices. So yeah, I am not sure if other things are like, why don't you stick to an industry convention? For instance, we have Linux Mini or Windows Mini. Android Go is not with Go language. Please, I'll share the resources. Try and read about that once. Go language is different. Might have used what backend there, but Android and Android Go are built with same tech stack there. Only a few features are disabled. So I hope that answers your question, Hadi. Then we have another question. In the Go edition, could I have some optimizations related to background tasks? Example, work manager, MVM, and things like use cases. You need to consider optimization as there can be so again, as I mentioned, the KPI for your application, right? Even if you are fixing some background task, you need to consider in which bucket that actually fills in. If are you fixing the that startup time, are you fixing memory, are you fixing app size, these are actually related also. But you could do again, the optimizations are same. Anything, these are just the low end devices, just consider them as a lesser RAM devices. Put put most of the things, again, if that can be put in the background task, keep your main thread as free as you can. This is the only key for any optimization. If you are keeping your main thread like free from the complex task, or maybe something which is taking longer, it will be free to do the things on time. Are the bitmap optimizations still used by there are some deprecations related to bitmap optimizations in Android. So what is happening is, we have seen that the third party libraries are there, but again, even these are using the LRU cache also. Optimizations, we have got new techniques for doing the optimizations. I won't say that things are like deprecated for, like everything is deprecated out there, but we have got new techniques to do the things. Maybe some data structures which could be used, or some frameworks which can be used and do the things. But yeah, we are still doing the bitmap optimizations. And even the most of the libraries which we are using for bitmap rendering, they are using these cache and the same the bitmap optimizations also. Can we use malloc in Kotlin? So what happens is, we deal with these in C and C++ code, the native code mostly. And so yeah, you must be using these there only. uh, then we have questions in, is recommended to use app startup library from Android X for avoiding eager initialization of an app in Go edition? Again, Go edition is the low end device only. If you have got something where you see there are a lot of libraries, and you are not able to decide which library to initialize where, how to initialize, and again, there are a lot of there, then there you could use this startup library and ask this type just request the startup library to do all this initialization. You don't really need to do anything apart from that then. So yes, you can use to use the app startup library also there. But again, you need to have a balance. If you are adding a library, that library should be of that worth in your code. Otherwise, again, you are just adding a new library and you're just increasing the app size also. Is there any restriction on what we can not add in application to release app for Go edition? We have disabled a few features. Like I'll give you just one example. Driver apps were not running because the picture-in-picture mode was disabled, and a few driver applications haven't considered the Go case. And you can see 250 millions were using 250 million devices are there for Go, right? And mostly the drivers had low end devices, the Go devices only. The driver user base, the application was not able to run at all for them. So there are restrictions. There are a few features which are not necessary, they are disabled. You could what you could do is, you could do to and search for Android Go documentation. I'll put the link also there, and just check what all things are disabled for your for Android Go. And again, if the device is having low RAM, then you can consider, or if device is like Android Go, just consider to disable all these features also. Driver can still use Google Map. You can use any application which is built for your normal, by normal I mean the main Android device. It just that it will again lower your memory, because anything why are we having the light apps? These are like the with the necessary features, right? You could use the Google Maps, you could use Facebook, WhatsApp. Why are we having WhatsApp Lite, Facebook Lite there? Because these run smoothly, and by just disabling some features, doing some optimizations, removing some animations, so you could use any application there. But still, again, you can't really go for uh, you can't really then have the smooth experience for all the application. One might be just one application taking the whole of the memory there. Can Flutter apps work well on Android Go edition? That's again a very good question. We haven't really tested that, but again, as the tech stack is same, you need to once validate that for your application, the complex features out there, how much memory your application is taking. So you need to consider all these cases there. Yes. I don't really know. Like drivers can still use Google Map. Is it like for are you asking for the driver apps or like how? Because drivers do have their applications, right, where they need to check, sometimes they are on call, and they're you see the picture in picture mode. So for them, picture in picture mode really works well. They can do the task parallelly, and they do have, like, again, just a small screen there, right? So and if you are not considering these Android Go cases, you won't be able to do that. Google Map is something, if they are going for a particular location, right, and someone has already integrated something in their application, drivers won't be like going to another application to just fill the location and try to see the directions, right? They will do everything in application, right? So this is the use case why even most of you will see even Zomato, Swiggy, they have their own maps integrated also, right? And the same happens for the drivers also. I have seen the in maps in the applications there. Do we need to make two different app code bases, one for light and other is main? We have some balance out there. You need to consider again, there are many possibilities. If your application is too complex and you can't really disable the features, you might need to have two, not just two code bases. You might again just have separate modules in just one code base for running for and making Android Go and the main Android applications. But yes, otherwise, there you just need to consider the low RAM cases and disable those complex animation and GIFs if your application allows that. Otherwise, you need to really have, if the complex features are there, GIFs are there, and you can't, your application is based on that only, right? Then you need to consider the cases and decide on if one code base can work or if two modules should be able to work for your application. How do we test Go edition apps without actual hardware? You have the Go devices, right? You just need to have the low end devices, the 1 GB 2 GB RAM, like I just mentioned, Geo phones. There are Nokia phones, Samsung phones available. You could test out there in on these devices out there. When will someone with regular Android can make the transition to Android Go with official ways? I don't. When will someone with regular Android can make the transition to Android Go with official ways? I don't really get this question. But what I am getting here is, now you do have the documentation, official documentation, the official ways of how you could work with Android Go applications also. If you have asked that question, I am not really sure if that is the question, because I am not able to understand this question really well. Do we have more question? Android Go emulator, we don't specifically have things. What you can do is, again, you need to, as someone mentioned, the hardware thing. You need to have all these. You Whenever you are building the emulator, you need to consider the low RAM cases and the low end processors. If you're getting that, then only that can be there. But I haven't really seen that Android Go emulators are people really using. What they do is they test on a low end device, and if something is working really well there, they just consider it to be like a go, that they can go with that. But yes, whenever you are building an emulator, you need to consider that low end processing and the low end memory case there for the emulator. And you can lower that, right? You can lower the memory for your emulator also, so you can build that. If the app is not optimized for Go edition, it will be visible in Play Store for them. uh, app for So Play Store is common, actually. It's not like you are getting a different Play Store out there. What happens is, with Go devices, there is just one section which is like the recommended section where the light apps comes in. Otherwise, even the Play Store is common for main devices and the Go devices, Go edition devices out there. If your app is not optimized, that will be seen there, but there will be a recommended section which will show all these light application or anything which will work really well for those Go configured devices. For Android Pip model, I tried as low as 256 memory, but it was always supported. Maybe we need a Go device emulator as well. I think, yeah, yes. We have asked the team also about this because people really need to build that and lower things, but other things are the same as main Android. So might be we really need to have one Go device emulator. So that's a good feedback. We are already trying to have that too.
All right. I think we're done with the questions. Uh,
Okay.
yeah.
Thank you
Thanks
so
a
much.
lot, Niharika, for the amazing talk and answering the whole list of questions as well.